so you guys already know like the gates, right? You guys know the AND gate, this, right? So the truth table for the AND gate would look like A, B, and we have this function over here, right? So we have 0 0 0 1. So if we have like both of them equals to 1, so then 0 0 1 1 and 0 1 0 1. Okay, so if we have both of them equals to 1, then it's 1, otherwise it's 0, right? But if we have the NAND gate over here, so NAND gate is basically like you have an AND gate and then you're putting a NOT gate in front of the AND gate, so it becomes a NAND gate. Okay, so the symbol will simply look like AND gate, but since you're putting a NOT in front of it, so you're just gonna put it like this. So this is the symbol for the NAND gate. Okay, so just remember this symbol for the NAND gate. And what about the truth table? So the truth table that you see, so for the AND gate, like I said, if we have both of them equal to 1, then it's equals to 1, right? So it's just gonna be inverse of it. So every time we have both of them equal to 1, then it's gonna give you 0. Okay, so that means this becomes 0, and every time, and the rest of them, so it becomes 1 1 1 1. Okay, so I hope it makes sense. It's simply going to reverse the original truth table you had. Every time you had like 1, it's gonna make it 0, and every time you had 0, it's gonna make it 1. So the logic behind is simply because in the AND gate we have okay, for the NOR gate, so if we have a simple OR gate, so we have the truth table, we have the logic gate looking like this, right? But if we are putting a NOR gate, so NOR gate means in front of the OR gate we're putting in NOT. Okay, NOT gate. So that means it's gonna be equal to, so this thing, it's going to be equal to doing this, the OR gate, and then we have like a little circle in front of it. So this is how you're going to draw the NOR gate. Okay, so just remember the symbol for the NOR gate. And what about the truth table? So for the truth table, the normal OR, every time we have a 1, we put a 1, right? But here, every time we have a 1, we're going to put what? We're going to put 0 every time we have a 1. Okay, just like exclusive OR E, B, and F, 0 0 1 1 0 1 0 1. Okay, now the XOR gate, or also called exclusive OR gate. Okay, so as the name suggests, so what this means is like in the OR we had like one or the other, right? So we had like one of them or the other of them, right? So but we also had for both of them, right? If we have like both of them 1, so we put a 1, right? So every time we have 1 1 1. So this is for the OR gate, the normal OR. But this exclusive OR means OR, but not when both of them are equal to 1. So every time we have both of them equal to 1, that's gonna be 0, but the rest of them, it's same like the OR gate. Okay, so that's the only difference. And the symbol, it's gonna look like this. So you have like an OR gate, but you have a little symbol like this. Okay, so that's the symbol for the exclusive OR. So yeah, every time the sum is equals to the odd number, we're going to Xnor gate. And yeah, one thing I forgot to mention, if you're asked to find like the function of this one, so function, it's simply easy because it's like one or the other but not both. Okay, so that's gonna be like AB or BA, right? Okay, for the exclusive NOR gate, so what do we do? Exclusive NOR gate is also called the even function. That was the exclusive function, right? We have XOR function, but now we have Xnor function. So Xnor function, this is also called the even function. So what we're going to do, we're going to put a not in front of the exclusive OR. Okay, so the symbol, it's going to change into this one, but then we are going to put like the negation in front. So this is the symbol for the Xnor. It's also called the even function. So what do we have over here? It's since it's an even function, so every time the sum is equals to an even, so then we're going to put a 1. So 0, it's an even number, so that's why I put a 1 over here, because the sum is equals to 0 over here. The sum is equals to 1, that's an odd, so we put a 0. The sum is equals to 1, it's an odd, we put a 0. The sum is equals to 2, 1 plus 1, that's 2, that's even, so we put a 1 over here. So that's the truth table. And if you want to find the function over here, so which is, because we're putting like a not in front of the exclusive OR, so the exclusive OR is like not A, B, or not BA, right? So we're simply doing the complement of this one for the even function for the Xnor.